linear momentum, impulse, and collision. Let's get started with linear momentum, then we'll do impulse, and then we'll do collision. Let's start with linear momentum. Okay, so we are looking at linear momentum. We need to understand what linear momentum is. Linear, we're talking about a straight line. This is linear. Circular, something in a circular manner. But our focus at this level, we are focusing on linear momentum, not circular momentum or radial momentum. Okay, so let's define what linear momentum is. So when you're talking about linear momentum, this is just the product of mass and velocity. That is linear momentum. It is just the product of the mass and the velocity. We are talking about velocity here. Velocity is a vector. It's a vector quantity. Same applies to linear momentum. Linear momentum also is a vector. So we are going to represent it as momentum with a bar because it is a vector. So let's now look at the formula which we can use to calculate linear momentum. So linear momentum is equal to, from our definition we said it is the product of mass and velocity. So it is mass multiplied by the velocity. So what does it suggest? So this suggests that this momentum depends on, the linear momentum depends on mass and what? And velocity. This is what the formula is suggesting. So linear momentum depends on the mass and the velocity of that body. Now let's look at the units. So since we are saying linear momentum is equal to the mass multiplied by the velocity, mass, the units are kilograms, the SI unit. Velocity, the SI units are meters per second. So the units now, the units for linear momentum are kilogram, meters per second. So these are the units which we can use when you're dealing with linear momentum. What if you are asked to express this in dimensional analysis? What are the dimensions of linear momentum? So here, since we are saying linear momentum is equal to the mass, product of mass and the velocity, and when you're talking about the mass, the dimension is capital letter M. Velocity is just the displacement, the change of displacement with respect to time, right? That is what is known as velocity. So it is change in displacement over time. And displacement, the dimension is length, and the time, the dimension is capital letter T. So the dimensions are L divided by T. So these are the dimensions for linear momentum. Now let's look at an example. How can you calculate? So let's say you have shot, this is a gun, so a person has shot at something, let's say a wall, then the mass of this is 10 kg of this bullet, and then this is the mass, then it has been shot at the velocity of, let's say 15 meters per second. Then you are asked to calculate what is the momentum of the bullet. So you use the formula, linear momentum is equal to mass multiplied by the velocity. So that is to say, linear momentum is equal to the mass is 10 kg multiplied by the velocity, which is 15 meters per second. So what will be the linear momentum? We just say 10 kg multiplied by 15, that is 150 kilogram meters per second. So that is how you can find the momentum. Then we need to understand that this linear momentum can be expressed in terms of x, in terms of y, and also in terms of z. Let's say the momentum in this direction, which is the x-axis. So for this one, we are going to say linear momentum in x is equal to the mass multiplied by the velocity in the x-axis. It can also be expressed or resolved in y direction. So we say momentum in y will be equal to the mass multiplied by the what? The velocity in y. But it can also be expressed in terms of z direction, that is y, x, and z. So in terms of z, we say linear momentum in terms of z will be equal to the mass multiplied by velocity in z. But of course, this is not our focus or our interest at this moment, but you just need to know or have an idea that linear momentum can be expressed in these forms. But our focus mainly is the linear momentum in terms of x and in terms of y. Now let's look at how you can find impulse. We've discussed momentum. Now let's look at how you can find impulse. What is impulse? So impulse is just the product of force, which is the net force, and change in time. Impulse is the product of force and change in time. We can also define impulse as impulse is equal to the change in momentum. You can also define it as this way. Let's look at how you can derive the formula for impulse. From our second law of Newton, we say net force is equal to mass multiplied by the acceleration. But we know that acceleration is equal to the change in velocity over time. Acceleration is the change in velocity over change in time. That is how we find acceleration, right? So you can substitute acceleration by change in velocity over time. So we're going to say net force is equal to mass, where there is acceleration, we put change in velocity over change in time. Then at this point, we know to say that when you have this is the mass, this is the change in velocity. Okay? You can write something as this. So you can say net force is equal to mass multiplied by change in velocity over change in time. But we've just looked at the change in velocity multiplied by time, which we are calling momentum. So we discussed that momentum is equal to the mass multiplied by change in velocity. So we can now substitute where there is mass multiplied by change in velocity, we can substitute change in momentum. Okay? So what can we have now? So what we are going to have is that net force will be equal to the change in momentum over, there we've substituted the change in momentum over change in time. Okay, so what do we have? Since we have net force is equal to change in momentum over change in time, we can say change in momentum is equal to net force multiplied by change in time. But remember, we said that change in momentum is simply impulse. From the second definition of impulse, we said impulse is equal to the change in momentum. So what are we having? So what we have is impulse is equal to force multiplied by change in time. So that is how you can calculate impulse. So what are the units for impulse? Now let's look at the units. Since we are saying impulse is equal to force multiplied by change in time, the units for force are simply newtons, for time seconds. So these are the units for impulse. So that is how you can calculate impulse, just the force multiplied by the change in time. Let's look at an example. Let's say a force of, let's say 50 Newton strikes a hole. So there is a collision, strikes a hole, and the collision takes 2 seconds. What is the impulse? Find the impulse. So how can you find the impulse? So we say impulse is equal to force multiplied by change in time. So impulse will be equal to the force, that is 50 Newton, multiplied by the change in time, that is 2 seconds. So our impulse, 50 multiplied by 2, that is 100 Newton second. So that is how you can calculate the impulse. Now let's look at what is known as the impulse momentum theorem. Impulse momentum theorem. So this is just a theorem which says that the impulse is equal to the change in momentum. Impulse is just equal to the change in momentum. But we know to say change in momentum is equal to the final momentum minus the initial momentum. That is how you can find the change in momentum. So you can even say that impulse is equal to the final momentum minus the initial momentum. But we know to say momentum is equal to mass multiplied by the velocity. So we're going to say impulse will be equal to the mass multiplied by the final velocity, that is final, minus mass multiplied by the initial velocity. So you can also use this formula to calculate impulse in a situation whereby you've been given the mass, the final velocity, and the initial velocity. Now let's look at an example on how you can apply the impulse momentum theorem. Let's say you've been asked to say this person is playing cricket. This person hits this cricket of mass that is 2 kg. Then the velocity there is 30 meters per second. Now the question is, find the impulse, find the change in momentum, okay, so these are the questions. Find impulse and also the change in momentum. So how are we going to calculate? So let me go to the next slide. Okay, so what we have, the data we have is that the mass is 2 kg and the final velocity is 30 meters per second. Of course, let's say this is from rest. From rest, the initial velocity will just be 0 meters per second. So how can you apply that concept? So initial velocity is equal to 0 meters per second. So how can you find the impulse? So impulse, we are saying it is the change in momentum. Impulse is the change in momentum, and change in momentum is equal to mass multiplied by final velocity minus mass multiplied by initial velocity. So this will be equal to, what is the mass? The mass is 2 kg. What is the velocity? Final velocity is 30 minus the mass, which is 2 kg. Initial velocity is 0. So this will give us 2 times 30, that is equal to 60. 60 minus 0, that is just 60. So we know the units are Newton second. So the impulse is 60 Newton second. Then what is the change in momentum? The change in momentum is simply the final momentum minus the initial momentum. Of course, since we know that impulse is equal to the change in momentum, so change in momentum will also be 60 kg meter per second. So that's how you can find the change in momentum and also the impulse. Let's look at another example whereby a car, maybe this is a car, so this car has a mass of 150 kg. Of course that is too small. Okay, 150 kg. Then the initial velocity of this car is, okay, so the initial velocity of this car, let's say this car is moving. This car is moving. Then after striking a wall, in fact, let me write it in this format. So the wall is this side. This is a wall. Then this car is moving. It is moving with the initial velocity of 15 meters per second in this direction. Then it accidentally hits a wall and rebounds. To rebounds mean that it hits, then it is pushed backward. That is the meaning. So we're saying it rebounds. Then after it rebounds, the final velocity is 20 meters per second. Then the question is find the impulse if the collision took, so the time, if the collision took, let's say 2 seconds, find the impulse if the collision took 2 seconds, and also find the momentum. Find the final momentum, like that. So find the impulse and find the final momentum. So how can we calculate this? So let me go to the next slide. Okay, so let's now calculate. So the first thing we've been asked is to find the impulse. So impulse is equal to the change in momentum, right? And we know impulse, since momentum is, change in momentum is final momentum minus initial momentum. That is to say, final momentum mass multiplied by the final velocity minus mass multiplied by the initial velocity. That is the meaning of change in momentum. So our impulse will now be equal to, what is the mass? The mass, have we been given the mass? So the mass of this car was 150. Mass was 150 kg. So we're going to say 150 multiplied by the initial velocity is, the final velocity. Final velocity is 20, like that, minus 150. The initial velocity is, since it is going in this direction. So when you are dealing with momentum, it is very important to take into consideration the direction of the velocity of an object. If it is going to the left side, the velocity will attract a negative sign. So it will be negative 15 meters per second. So that will be the initial velocity, negative 15 meters per second. So what will be the impulse? So we can just compute this using a calculator. We can say, what is 150 multiplied by 20? That is 3000. Then minus 150 multiplied by, so this will be plus now, because negative multiplied by negative is equal to positive. So 150 multiplied by 15, that is 2250. When you add plus 3000, the answer will be 5250. So this is the impulse. So the units will be Newton second. So that's how you can find the impulse. Then calculate the final momentum. So final momentum is equal to the mass multiplied by the final velocity. So what is the mass? It is 150 kg. What is the final velocity? The final velocity was 20 meters. So multiplied by 20 meters per second. So 20 meters per second. So our final momentum will be equal to 150 by 20. 150 by 20. 150 multiplied by 20. That is 3000 kilogram meters per second. So this is our final momentum. So we'll end on impulse momentum theorem. Then in the next part of this video, we're going to do elastic collision, inelastic collision, and glancing collision. Since we've already done the momentum, we've discussed impulse and the impulse momentum theorem. So do the last part of this, then we'll be done with linear momentum, impulse, and collision. Thank you for watching.